Morning, I am Srilekha, Department of Chemistry. On the previous sections, we have learned about the introductions to nanochemistry. Now, we are going to see about the applications of nanotechnology, and the nanotechnology is defined as a design, characterizations, productions, and the applications of structures, systems, and devices by controlling sizes and shapes at 10 to the power minus 9 meter scale or the single atomic level. Next, the distinctions between the particles, molecules and the bulk materials. So whenever the many properties of the solids depends on their sizes at the macro or larger scale range ordinarily studied in the physics such as mechanisms, electricity, magnetism and optics, the size of the objects range from millimeter 1 into 10 to the power minus 3 meters to kilometer 1 into 10 to the power 3 meters. Their properties are the average properties. When the measurements are made in macrometer 1 into 10 to the power minus 6 meters or nanometer 1 into 10 to the power minus 9 meter ranges, that is the nanomaterials have entirely different properties. These are given in the followings. So the first one is the size of the nanoparticles are less than the 100 nanometer in diameter. Molecules are in the range of picometers, but bulk materials are in the range of micron sizes. Molecules is a collection of atoms. Nanoparticles are the collection of few molecules, that is less than 100 nanometers, but bulk materials contains thousands of molecules. Surface area of nanomaterials is more than the bulk materials. Strength of nanomaterials is 3 to 10 times higher than the nanomaterial, possess size dependent properties, but bulk material possess constant physical properties. Corrosion resistant is more than the bulk materials, hence localized corrosion in nanomaterials is stopped. Behavior of bulk materials can be changed but cannot enter inside the nanoparticles. Nanoparticles due to its sizes possess unexpected optical vision properties. So the size of the nanoparticles, that is 1 to 10 to 100 nanometers and 1 to 10 micrometers, that is the bulk materials. Formation by a few molecules by more than 1000 molecules. Surface area very high, and it bulk materials it should have the low types. Ductility it should be a high and the low. Strength and the hardness and the toughness it is should be in very high and low. Corrosion resistance is high, low. Wear resistance high, low. Density low, high, and the melting point low, high. Sensing time that is low, high. Thermal conductivity is low, high. Electrical conductivity is low, high. Elasticity that is low, high. Properties depend on their sizes, do not depend on the sizes. Iron, nickel, supermagnetic, ferromagnetic. Sodium, potassium, ferromagnetic, paramagnetic. Chromium, paramagnetic, antiferromagnetic. Color of the gold, deep red to blue, yellow. So in this the manners, the nanoparticles due to their sizes have their visible properties, which is the some formations to have the properties. Examples: gold nanoparticles appears deep red to black color in solution compared to yellow color with gold. Zinc oxide nanoparticles possess a superior UV blocking properties compared to the bulk materials. The nanoparticles possess lower melting point than the bulk materials. Gold nanoparticles melt at low temperature 300 degrees Celsius for 2.5 nanometers, but gold slab melts at 1064 degrees Celsius. Sintering of nanoparticles takes place at a low temperature and in short time than the bulk materials. Electrical properties, resistivity of nanoparticles are increased by 3 times. Suspensions of nanoparticles is possible because the nanoparticles possess high surface area, but bulk materials cannot. The wear resistance of the nanoparticles are 170 times higher than that of bulk materials. So whenever the bulk materials have been compared with these properties, the nanoparticles which should have, it consists of mostly of two atoms. It consists one or two or dimensions. It consists of three-dimensional arrangements of a large number of atoms. Their properties are size dependent and the properties are size independent. Their sizes are intermediate between molecules and bulk materials. Their sizes are larger than molecules and nanoparticles. The sizes are expressed in nanometer. Their sizes are expressed in millimeters. Their electronic structures is confined. The electronic structure is continuous. They have well-defined geometrical structures, and the nature of the bulk materials decides the geographical structures to have the properties. So for this we can have the examples of HCl and the CaCl crystal structures. Thank you.